Today we're going to look at solving for sides and angles in a right triangle. So our first example, we know the measure of angle B is 67 degrees. The length of the hypotenuse is 20, and we're solving for A. So using SOHCAHTOA, from the angle, I'm looking for the adjacent, and I know the hypotenuse. So I'm going to set up the cosine of 67 equals adjacent over hypotenuse. So to solve for A, I'm going to multiply both sides by 20. And 20 times the cosine of 67, rounding to 3 decimal places, is 7 and 815 thousandths. To solve for an angle, we set it up the same way. We're looking for the measure of angle B. We know the opposite and the hypotenuse, so we're going to use the sine of angle B equals opposite over hypotenuse. So to solve for B, we use the sine inverse or the arc sine function, depending on how your geometry teacher worded it. It's the same thing. You'll find it on your calculator. It'll have a little -1 above it, and typically you hit the shift and the sine button to find it. So if you're having trouble looking at your calculator finding it, just let me know when you get to class tomorrow. For degrees, I'm okay if you just round to 1 decimal place, but in this case, it actually rounds us up to 38 degrees. Sorry. Let me clarify that. To solve a triangle, what that means is to find all missing sides and angles. So we need to find the measure of angles A and B, as well as the length of side AB. So for AB, we can go ahead and use Pythagorean theorem. And 49 plus 4 is 53. And typically you're going to give it in simplest radical form. 53 has no perfect square factors, so we're just going to call it square root of 53. To solve for A and B, we will use SOHCAHTOA. And I am going to use the two sides that aren't under radical. I'm going to use 2 and 7. So to solve for A, I'm going to say the tangent of A is opposite over adjacent. This is another one where we'll have to use the tangent inverse to solve for the angle measure. And I got measure of angle A is approximately 15.9 degrees. So I could use trig to solve for B, or I could just do 90 minus 15.9, and that gives us 74.1 degrees. Next worksheet, we're going to be looking at angles of elevation and depression. An angle of elevation is formed by a line of sight up. Now notice it's a horizontal line. Now for angles of elevation, typically my students don't have an issue with that. What they have a hard time with is angles of depression, even though it's the same thing, formed from a horizontal line and a line of sight down. You wouldn't think it'd be too challenging, but when you get to word problems, typically students try and use a vertical line and a line of sight down, because in a word problem, when you're setting up the picture, it typically makes more sense to use a vertical line, or it seems like it based on the information. So be very careful with your angles of depression. Make sure anytime that you're setting up your angle, you're using a horizontal line to start with. All right, so first off, I know it says word problems. This isn't actually really a word problem. We're just solving for the width of the river. We've got a picture going on here. So we'll use our trig. From this angle, we have the opposite and the adjacent. There's our right angle. So we're going to set up the tangent of 48 equals, we're looking for the opposite, and we know the adjacent. Multiplying both sides by 25, we get the width of the river is approximately 27.765, and we don't have any units. A cliff is 150 meters above the sea. We have an angle of depression. So the first thing I'm going to do when I see the term angle of depression or angle of elevation is I'm going to draw a horizontal line and a line of sight. If it's a depression, a line of sight down. Okay, so here's our cliff. And it's 150 meters above the sea. Okay, so here's our sea. A boat in the sea, here's our boat, measures 8 from the cliff. The angle of depression measures 8. Sorry, that degree symbol got separated from it. How far is the boat from the base of the cliff? So once we've got our picture set up, I hope you can see why most students try and put that angle of depression right here instead, because that's inside the triangle we're kind of starting to form. That is not the angle of depression, so please don't do that. What you can do instead is, these are complementary angles. So you can do 90 minus 8 and get this as 82 degrees. We have this 150 meter side. Here's another right angle the cliff forms with the sea. So we're looking for x. Again, we have opposite and adjacent, so we're going to use tangent of 82 equals x over 150. Multiplying both sides by 150, we get the boat is about 1,067.305, what were our units, meters away from the cliff. Final example. This time we have an angle of elevation. So start with a horizontal line, line of sight up. A plane is flying at an altitude of 10,000 meters. The angle of elevation from an object on the ground to the plane measures 28 degrees. So our plane is 10,000 meters in the air. And the question is, how far is the object from the plane? Now remember, here's our plane. So this is the value that we're looking for. Not how far away is it from where the plane would be if it were on the ground. How far is it from where the plane actually is? All right, so we have opposite and hypotenuse this time, so we're using sine of 28 equals 10,000 over x, multiplying both sides by x, and dividing by the sine of 28. You have x is about 21,300.545 meters away from the plane.